Hi, everyone. Welcome, first of all, to this presentation. Thanks a lot for being here. I have a lot to share, but we just have an hour of time. So I'd like to just make sure, again, to repeat that we have the ability to ask questions just using the chat functionality that you'd see in your Zoom environment. Somewhere all the way at the bottom in your screen, there is this little chat button. It opens up a little chat window, and it allows you to ask any questions that you might have to me or to the entire group. My name is Ali. That's me over there. My name is Ali Hajou. I'm a total Agile nerd. And I've been, for the last couple of years, I've been really invested in the sort of researching and finding out and figuring out actually how Agile operates in the world of hardware. And there are different words for that. Some people call it hardware. Some people call it engineering. Some people call it for products. So Agile in the use of using Agile in product development, or maybe physical product development, machinery, electronics, manufacturing. There's so many more terms. So if you have any other alternatives, feel free to add them into the chat, because I just, I want to understand which terminologies are being used in your environment. First of all, who am I? And I'll just briefly talk a little bit about the person that is talking to you right now via this digital screen. I am a transformation architect, which basically means I'm involved in trying to tweak the Agile way of working for a specific context. And you'll see also during this presentation is that the context differs everywhere. But the basis and the ideas, they might be the same. And actually, some of the ideas might be very copyable, or maybe even you can get inspired by ideas from completely other environments. For instance, I'm going to share a little bit about how it operates in the development of medical devices. And the regulation around it, and perhaps that helps you as a little bit of inspiration to find your own Agile way of working in your context, which I have been doing as a consultant, as a trainer, associated with Keygon as an SPCT, which is a SAFE, which is one of the frameworks, Safe Practice Consultant Trainer. So I host trainings in these kind of things, which is approximately about 10% or so of my time that I do that. The majority of my time is spent in finding Agile ways of working in, hardware contexts. All kind of acronyms that I've collected over the years. If you have any interesting acronym, then feel free to share that, because then I'll do another course. I see that Oliver has already shared agility in systems development. I really like that. I've heard Agile in systems engineering already, and there's a lot that has been published about that topic. So a huge body of knowledge that we could all dive into. And you'll see at the end of my presentation, which will take approximately 45 minutes or so, you'll see that there are all types of little groups or communities that you could tap into to learn more from others, which is really nice. I live in the most beautiful city of Europe, which is Utrecht, a small little village, actually a little more than that, a little city in the middle of the Netherlands, travel throughout the Netherlands and throughout Europe to help out companies in finding their Agile way of working. Most specifically, I've been helping out NXP, which is semiconductors, for instance, in the area, who has been developing the 5G chip into about 2017, 2018. Schneider Electric, which is a company creating basically everything that has electricity going through it. from cables to lamps to switches to cable gutters to machines to motors, a huge amount of like a large portfolio that they have. ASML, a company that creates giant printers, but instead of paper out of the printer, what we have is silicone wafers. So that is a 300 millimeter or 450 millimeter silicone wafers that has chips printed on it. So I'll talk a little bit more about them as well. A company called Van der Lande, organizing essentially anything related to transport, baggage handling on airports, and package handling for companies like DHL and more parcel logistics. So today, I would like to guide you through a little bit of an issue, a little bit of a disaster that we see in our industries. A disaster that is becoming bigger and bigger over time. What do I mean with that? Let me just open up some material that is publicly available on all types of websites, and what I've taken along is a report from the European Commission that states, or that talks about staff shortages. Staff shortages. There is a shortage that is a serious problem in the majority of European or SMEs, subject matter experts in EU. We have a huge amount of issues finding the right employees. Why? Well, we're building more products. We are having more products out there as installed base in our at our clients or out there into the market, which needs to be maintained. We have all kind of new ideas to improve our technologies, our products that need to be more connected, that require a way higher standard in terms of security standards and regulation. So there's more work that we need to handle. The typical approach of handling more work is to hire more people. That's typically what happens. However, finding the right people is very tough. And on top of that, if we look at the, let's say if we zoom in on what type of people we are searching for within Europe, we see that people with technical skills are just extremely difficult to come by. And there are all kind of reasons for it, and you might feel it, you might see it already in your own environment, you might feel it in your own company, you might experience that in your own team. But people with core technical skills are becoming more and more rare for all types of reasons. For instance, there is an aging population in terms of core technical skills. Back in the days, I think more people followed, how do you call that, schooling to become a mechanical engineer or an electrical engineer or an engineer in optics or understand industrialization and mass manufacturing. These days, less and less people are, moving away from the universities with that type of degree. Perhaps maybe that's because of the interest of the youth these days. Maybe there's sort of a different, how should I call it? Level of interest in these type of topics. Which is really sad because everything that we use, that we have installed in our houses is built by people and it's being used by people. So I think there's a lot of really cool stuff that we can spend our time on. So somehow the tech industry or tech studies are becoming less and less interesting, which has a direct impact on the amount of people that become available onto the market to become part of our teams, to be able to develop new and novel technical products. On top of that, things are just going so fast. I don't have to iterate that for you. There's rules and regulations that are really speeding up and having a direct impact on the technological product that we have, that we need to build. And on top of that, it takes quite a long time to onboard people within the company or within your team. Simply because whatever we are creating is becoming more and more complex by the day. So this issue is we need to somehow tackle that. And on top of that, what kind of impact it has at the moment on the people that are already operational in the tech industry is that there is a dramatic decrease of popularity of these technical roles, and we need to somehow adapt. And the people that are currently in the environment, they experience an increased workload. So more and more things that need to be done with perhaps even less and less people, and that might have on a business side that might have an impact on the sales. Simply because products don't get ready in time. There is delays where we've experienced quite dramatic shortages in the market from our suppliers, and all of that has sort of a knock-on effect on which products we can bring to the market in time, which is a waste, because the manufacturing industry, or the hardware industry, how I like to call it, is huge. In Europe, there are more than 2 million enterprises who develop physical products. So let me rephrase, physical technical products. So that is whether it is high tech, but at least technical products to the market, which is in total more than 6 trillion in turnover. Which is more than 15% of the total share of the EU's GDP. At least that's how it was in 2022. The manufacturing industry, or the hardware industry, it constitutes more than 32 million jobs just in Europe. So it has a huge impact on let's say how Europe does its work, and what is being delivered within Europe. And the thing is, handling an increased workload and making choices on what to spend our capacity on, that is nothing new. Traditional project management has been, let's say, set in place, has been created to be able to understand triple constraint management, really to understand what are we going to do with the capacity that we have, or with the limited resources that we have. That's nothing new. And on top of that, in the world of Agile, we've been battling the same triple constraints forever. We have limited amount of capacity, we have limited amount of resources, therefore, and we have a huge amount of things to do. So we need to make choices. And what Agile has given us already for more than 20 years is an operating model, sort of a way of thinking, if I can call it like that, but more specifically, what came out is all kind of ways of working, operating models to make choices. However, where did that start? If we talk about Agile, we saw that Agile has been, let's say, experimented, adopted a lot in core IT, software development. So you'll see that software development, let me rephrase, examples of using Agile in software development has been published about. There are books about it. There are all kind of nice examples that you can find on the internet about how that works. The same with using Agile in all types of financial industries, whether it is for software development, for marketing, for sales, or for, let's say, service management. All of that has been published a lot, simply because people had time, companies had time to experiment, to establish it, and to publish it onto the web or write it into articles and books. However, what we see, and I'm very sure that you see that as well, is that even though Agile might have started in the IT environment or in the software development environment, whether it is embedded software, whether it's software platforms, it has a domino effect. It has sort of a knock-on effect on the worlds of manufacturing and construction. And the thing is, what we see is that more and more is being published about that. More and more companies are sharing that the Agile way of working is becoming their standard operating model for handling work, handling the dramatic and huge amount of work that we need to somehow select our spend our time on. As a matter of fact, Felipe Engineer is the author of Construction Scrum, the book that is shared on over here on the shared screen, has been very vocal about all of the projects he's been involved in using Agile, or more specifically Scrum, in the world of construction. That is construction of buildings, offices, and factories. And has published a really nice book about construction Scrum. As a matter of fact, all the way at the beginning of the book, if you'd open up the book, the first words in it is he's thanking Ali, but only later I figured out that Ali is actually the name of his wife. But nonetheless, I still really appreciate his thank you words. But more than that, there are so many other books that have been published already for quite a while. For instance, a book called Industrial DevOps by Dr. Suzette Johnson and Robin Yeaman, who talks about the use of DevOps, development and operations, that is development and maintenance essentially, in small little stable teams that are operating using agile practices and and having an agile mindset, but doing that for machines and complex systems such as satellites. Paolo Samichelli wrote, I think this is already his second book, about how Scrum works for hardware, with all types of examples that he has also published on his website. So there's really a lot that is being shared on the web and in books about how, let's say, Agile as we know it has been tweaked to benefit the world of physical product development. And that's where the issue also is. Whenever we look at the different companies that have been using Agile and have been let's say, public about it, and there are so many, but so I've just selected a few over here. I know that Siemens Healthineers, I know that Bosch, I know that Mercedes-Benz and Audi have been collaborating with Keygon. Myself, I've been involved with ASML, with Schneider Electric, with Van der Lande, a little bit with Philips. In creating operating models, ways of working that benefit small, little, stable teams that have electrical engineers, mechanical engineers, optics, industrialization, technical authors, but also embedded software and way more. But each of these companies have a slightly different way of working. And that's typically, and I wonder how you're all sort of experiencing it. It's typically it's like a direct stop of discussion. What do I mean with that? Because each environment has a slightly different way of working, we directly say, you know what? That information that you just shared comes from automotive, but we are from the pharmaceutical industry. We develop medical devices, so whatever you just shared with us does not apply. Or we have onboarded a certain agile way of working, a certain operating model to scale agile. For instance, the Scaled Agile Framework, or in short, SAFe. We have been operating in a safe environment for a very long time, but in our discussions, you talk about rapid learning cycles, which is a different operating model. It's a different way of working, so it doesn't apply to us. Hence, I stopped listening essentially, and I think that's it's a waste. Unfortunately, there's so many good practices that have been embedded in all of these different frameworks or in patterns that might be beneficial for you, but it requires you to dive into these frameworks. It requires to see what works for you in your specific context. And there are quite a few of these frameworks that have been pre-created for you, and perhaps they are, you can use them right off the bat, such as MAD, the MAD framework, that is MAHD, which is essentially a scaling framework for applying Agile in a hardware environment, so for hardware development. Or rapid learning cycles from Catherine Radica, which is also a way of working in which we talk about small little stable teams that operate in learning cycles and develop physical products. As a matter of fact, she has published quite a lot on her website about how, for instance, SunPower, Trimble, Novo Nordisk, Breville have been using this framework to, in a way, contextualize Agile for their hardware teams. So it is possible, but you need to search for the details yourself. That's the unfortunate thing. Because just diving into a framework or searching for a framework that fits your direct local context one-on-one is going to be quite tough. Why? A while back, I did a little bit of research of what type of Agile frameworks do we have at the moment, in the sense of which ones are published. And I stopped counting. I stopped counting at 42. It's a huge list of frameworks, as you could see over here on the shared screen, that some of them are really applicable in certain environments and some absolutely not. So there are so many different frameworks that might apply. But I think that's where the gist is. The gist is in the ability to dive into the different frameworks and see, what part of which framework works best for you. What is sort of the issue that you're trying to solve. But that's a very bad note to end on. So let's dive. I'm going to share two different let's say approaches, which are that are quite, let's say, generic through all of these frameworks that might help you out. That might help you out in finding your Agile way of working in the context of, let's say, the product engineering process, or in the let's say in your context. So now what? What I would like to highlight today is the switch that you typically see happening whenever we move to a more agile way of working, which means that all of a sudden we're focusing much more on how people are organized. So that means that the people are actually the core assets. So rather than having the strategy of onboarding more people to handle the scope that we want to achieve, we typically don't have that luxury. So what do? We need to look at the capacity, so the resources that we have, and then organize around that. So figure out, what do we need to develop? What kind of people do we have, and competences do we have in our organization, and then see how we can utilize that as best as possible. Which means I'm going to talk a little bit about stable teams who outlive projects, rather than projects assembling a temporary team, and then whenever a project is done, the team is sort of dispersed, which means you lose all of the knowledge that has been nicely created together as a team, and you've finally found some efficiencies which you might lose whenever a project is done, and therefore the team is disbanded. I'm also going to talk about how small little stable teams actually help in blending senior engineers with junior engineers. talked about this, the quite a big ramp up of that is required for onboarding people. It takes a long time for a junior engineer to sort of understand exactly what needs to be done and how work needs to be done according to the internal practices. So I'll talk a little bit about that, and I'll talk about how to prioritize delivery over completeness. So having a heartbeat, sort of a fixed cadence, how that can be really beneficial for your environment. But let's start with the first situation. Imagine the following. We have multiple different project leads that all have the extremely difficult job to, in a way, finish a project. They get the responsibility for a project, so they have a project plan. They might have some scope that they need to develop more specifically. Each project manager also has a timeline, and with that timeline, they receive budget. And then what happens typically with that budget? They hire engineers. So the engineer in this example is Ali. That's it. That's Ali, the engineer. And Ali is just one single person. It's a specialist. And project lead number one doesn't need the specialist, the full duration of the project. No, the project lead needs Ali for 0.5 FTE. Fantastic. Project manager number two needs Ali for 0.4 FTE. And nothing more than that, because I don't have infinite budget. And project lead number three will need Ali at 0.3 FTE. And indeed, in Excel, it might work fantastic, but for the people that can calculate very quickly, it's too much. So the thing is, this does not have to be extremely, how should I call it? This shouldn't be painful or risky or faulty from the get-go. It can work very well, especially if the project leads talk with each other, amongst each other, so just to make sure that they can utilize the available capacity as good as possible. But what typically happens is that there is actually a split between each project manager, which is, of course, it makes total sense, because the incentive of a project manager is to make sure that his or her project gets done in time and according to budget. So in this scenario, there is just risk involved. In this scenario, we're moving people to the work, which is, whenever the project is done, the team is disbanded, because whenever the project is done, Ali is probably already allocated to another project. So you lose that knowledge that has been built up with the little temporary project team. And on top of that, the moment that Ali is working for project lead number one, let me say, Ali is completely focused on working on project number one, which is good. There is a little bit of focus, trying to finalize some deliverables, and all of a sudden, project lead number two comes up and says, Ali, I need you right now. Why? Because there is a huge delay at the moment, simply because there's something that you've developed a half a year ago that is right now blocking our colleagues in the manufacturing plant. So Ali, you're still allocated 0.4 FTE to my project. I need you in my project. Which also means, I'm like, okay, fine. I'm going to drop everything that I do, and I'm going to switch over to project number two and focus on that work, which requires me to spend some more time on reading, what has been done, how far are we, what was the issue again. I mean, what did I eat yesterday? I remember what I ate yesterday, but I even forgot what I ate the day before, let alone thinking back what I've developed a half year back. So switching to another project is inefficient. It's a lot of time involved switching back and forth. And that is switching time. Switching time is just inefficient. And that builds inefficiency in this system. And whenever I'm just busy with project number two, all of a sudden I get a request from project lead number three that something is burning at the customer site, which also means, I need to drop everything that I have in my hands and I need to focus on anything related to project number three. And then the same thing applies. So it's a very haphazard way of working, which can become very nasty. It can become very nasty. And this issue has been solved within agile teams for a very long time, because over there they just twist the way of working. They twist the way of working because Ali, as a specialist, is now all of a sudden part of a small little stable team that outlives projects. So how does that mean? We still have 3 different projects. We have project number 1, 2, and 3. But rather than moving the people to the projects, we're moving the work, so the project work, to the people. And that means that stable team will remain stable irrespective of which project is requesting capacity from the team. But the work goes to the people, which also means it is collected into a single one-dimensional list that we call a backlog. So it can be found in a single one-dimensional list that we call a backlog. And in a lot of environments that utilize Scrum or the Scaled Agile Framework or large-scale Scrum, we call the person who's managing that backlog a product owner. You've probably seen that before, you've probably heard that before, but we have a person who is prioritizing work and maybe even filtering work from different projects, which also means that there is a chance that work that is relatively low in priority, urgency, or let's say added value might not be done. It might be filtered out. Because if we just look at the total amount of capacity that we have and all of the work coming from the 3 different projects coming in, there's just some work that is more urgent than other work. So there's work filtering. The thing is, that already happened in traditional project management, but that was typically done by a project lead who said, you know what, there's a milestone approaching and all hands on deck. We need to deliver. So because we need to deliver, let's take some details out of scope. So the activity already existed. But right now we're bundling that activity around the capacity that we have. And in our case, that is, we're doing that around the stable teams that we design. The question that then follows is, how do we then do that? How do we create those stable teams? Because if we have stable teams, we cannot create stable teams around a project, because whenever a project is done, then the stable team is not relevant anymore. So we need to design a stable team according to another approach, another cross-section of the organization, or another cross-section of the product. And in order to explain that, I'm going to share you a little example from a company called ASML. And just using public information over here, so all of this can be also searched. You can go through the news article that I'm sharing in a second as well. The news article that I'm sharing over here is from Frits van Hout, who sent sort of a bye-bye message when he left the company in 2019. The article itself is called A Farewell to a Big Family of Top-Class People, of a company called ASML that is the most popular, the most successful, one of the most successful companies in the Netherlands. They're hugely influential in the entire industry of chip making. And in that bye-bye article, he shares a really nice little nugget of information, how this happened. So why is ASML so successful? So what made ASML stand out? And what he shared in his article is the following. ASML took a modular approach. They took a modular approach where they thought about the high-level system structure before they designed and built the entire system. And I'll share you a little picture of the system in a second. But they created a sort of a high-level system-level structure, sort of a design. They used a teppanyaki style. I'm not sure whether you've ever been to a sort of a Japanese restaurant that used teppanyaki, but like with a big knife, they chopped the large system into smaller pieces. And then organized around that. And that technique, that way of working, that thought, that approach, originally comes from software development. For our, the software development that are currently in the call, object-oriented programming. We understand that. We try to figure out what are the behaviors of the system, and then create an object around that, or at least what is the behavior of the system, and create an entity around that. They call that system functions in ASME. And there are many system functions in that large machine. The machine itself is huge and it's extremely complex. It generates extreme ultraviolet light using pulsing lasers that do that 50,000 times per second. And then with extreme ultraviolet light, they print essentially integrated circuits on silicon wafers. But these different cross sections of the machine, they've built it in the past. They are building it today for new generation machines, and they're going to maintain it for the installed base machines that are out there. So it's the system function it's a stable entity of the machine, and therefore it would be nice to organize people around that stable entity. And there's a lot of information that has been written about this. As a matter of fact, has been written about this and published very nicely in NASA Systems Engineering Handbook, which is freely downloadable if you just search for it in Google. NASA Systems Engineering Handbook, you search for the system behaviors and you organize around that. So what does that mean? So if we have stable teams that are organized around stable entities, stable parts of the machine that we're building or the product that we're building, then can we plan iteratively? Well, how does that work in the world of hardware? Rather than building one version of a module all the way until sort of end delivery date, what we're trying to do is to build smaller versions. Mark 1, which is typically an incomplete version, and then later a Mark II. And you try to space that out in time. So what is the minimum amount of, let's say, functionality, system behaviors, components that we can build into an entity that becomes verifiable and integratable? Which also means we have the ability to plan integration points. In NASA Systems Engineering Handbook, they call that key decision points, so milestones essentially. And while we have these long-term milestone plannings, we need to sort of adapt our, let's say, the work that we need to do in order to reach that milestones, to make sure that we have the flexibility to choose what are we going to work on. Which means we have a backward-looking planning, which is the traditional long-term planning with milestones. And on top of that, we also have a forward-looking planning, which we have in very, in extreme detail, which is typically in 2 weeks. We know that from Scrum, 2-week iteration, and for instance, on a quarterly basis. So on a 2-weekly basis, we're looking at, seeing, do we have any delays? If we have any delay, we see a milestone approaching in the distance, but we have less and less time. So can we descope something? Can we do something else? Can we build, from commonality point of view, can we build a platform or a component that can be reused in another part of the machine as well? Just to make sure that we can speed up in another environment or in another system function. So we are adopting our planning and the work that we need to do in order to reach those milestones continuously. We do that continuously. So the milestones, they stay. The milestones stay. Agile or not, the milestones stay, because the milestones we use to synchronize the entire company with each other, so with the company, but also with external suppliers. And as a matter of fact, if you have a marketing department who has already mentioned to the market that a certain product will be released at a certain moment, that's quite a hard milestone as well. So you merge those two, let's say, planning approaches on top of each other. But then, how do we do that? How do we do that and still remain compliant? Because there's all kind of rules and regulations that we need to do, and typically compliance happens all the way at the end. Let me just share a little brief detail about maybe something that you know in your context, ISO 26262, which is an ISO standard for functional safety. Used a lot in automotive and a little bit about outside of that, OEMs typically, which talks about remaining compliant from a functional safety point of view when developing a new product, a new car, or a new part of a car. And what typically happens is that compliance, there's a lot of compliance documentation that is being tracked throughout the project, but somewhere, at the end of the design phase, so in time of homologation, in time of mass industrialization, that's typically the moment when all of the compliance-related deliverables need to be finalized and need to be put together. So it becomes extremely stressful at that moment in time, and also extremely risky if we find out that all the way at the end there's something that we missed. In the context of, let's say, traditionally, how we do it traditionally, we have I'll just, I'd like to make things black and white. Compliance all the way at the end of the project. We have a safety manager. It's a person that needs to be appointed according to ISO 26262. A person that has the responsibility and the accountability for all types of deliverables related to functional safety. So that person is just running around constantly just to make sure that all of the information is written out, that there is traceability, that we are adhering to certain processes, and that people are trained accordingly, and that everything eventually ends up in the correct QMS, and to make it trackable and therefore to be compliant. But there are other ways. There are other ways that have been published about a lot as well, where we're not talking about, let's say, achieving compliancy at any time, but at least we're trying to get close to it. Not compliancy at any time, but we're trying to get very close to being able to be compliant at every time, which means we might have certain roles who act as a proxy functional safety manager or a safety manager. We might have different, let's say, contextualized agile roles that have some additional roles and responsibilities to make sure that we remain compliant. And this is nothing new, but it needs to be mapped. It needs to be mapped for your specific context. And there is a really nice example of a company that is supporting that, a company called Petco, located in Switzerland. They have a product and a service called Applied Safe. So they do this specifically for the Scaled Agile framework, which is really nice, where you could see the mapping between all types of regulation on the one hand and the safe way of working, the Scaled Agile framework way of working, which basically says, if you follow this method and this practice, then you're compliant with this role, with this responsibility, according to a certain regulation. More specifically, ISPE, which is from the pharmaceutical industry. They've published already in 2008 the Good Automated Manufacturing Practice, Volume 5. And they've been publishing a lot about the use of Agile in the development of software, but also medical devices using Agile teams. There's a lot out there that talks about an iterative approach of FMEAs, development interface agreements, so DIAs, having fixed cadence for stage gates, but then also sort of a stage gate completeness check in a way. So every quarter they check, can we pass a certain gate? It's really nice. And the existing software that we use for traceabilities, such as JAMA, IBM Doors, or Rational Doors, Siemens Polarion, they have these tools have the ability to develop documentation incrementally as well, and therefore have the traceability of how requirements progress through the entire life cycle of the product development as well. It is out there. It just requires research. It requires a little bit of sort of a deep dive. And the thing is, there is some challenges that you need to overcome, which is that, traditionally there's a sense of completeness that you might have all the way at the end of the project. We just, we have a checklist, like check. Do we have all of the documents? Are the documents signed off by the right people? Because then we're compliant. And with an agile way of working that requires way more involvement and way more speed, we need to be involved. We need to have much more involvement on a much more frequent basis with the engineering teams, so that we can guide them in remaining compliant early on in their development process, rather than trying to do that all the way at the end of the product lifecycle. Development process. So what I would like to end on is that, again, there's no one size fits all. There's no one size fits all. So it really helps to just dive into all type of communities that are out there to learn from each other. Thermo Fisher has been very open about their way of working. So these days they're called Thermo Scientific, about their iterative way of working in their product development. Company like ASML has been very open and have been presenting in all types of events, sharing how they created multidisciplinary teams, small little stable teams that are multidisciplinary, so they have different engineering disciplines within one small team. And that comes with all kind of additional challenges, but they share how they are going through it. ProAwareness, or more specifically, the Roundtable for Agile Hardware, chaired by Mireille Fink, is a free to join community. I think they have every month or every 2 months. They have a get together where you could just join these sessions and then share ideas with each other. You can hear from other companies or people from other companies how they apply Agile in their context. Our friends from Keygon have been organizing quite a lot. I'll be involved in anything related to Agile for physical product development. So we're going to publish more about this. There's Agile for automotive. There's another session that has been organized by Keygon specifically for the automotive industry and the partners and stakeholders in there. Somewhere in September, there's the Safe Leadership Forum organized by our friends from Keygon Schweiz, Switzerland. Incosi has a working group about Agiles and system engineering, which is also free to join. And you could even, if you're an Incosi member, you could get all kind of additional information and papers about that. Gladwell Academy, company in the Netherlands, has an Agile hardware community that they organize and bring a lot of people from different companies together just to share ideas and progress this thought, this way of working, this habit of using Agile in the world of hardware to benefit all of us. That's the thing. And for me, it has been a personal passion. So I'm learning still. I've been doing this since 2017, and with that, working with Agile since 2009. And it's constantly different. But having these small little stable teams that are organized around a stable something in your organization, and then moving work to them. And then having two different types of planning, which is a long-term backward-looking planning with milestones, and then a short-term forward-looking planning, which is your sprint review and your PI planning if you use SAFe. All really benefits. So there is a lot out there, and there's also a lot new to explore. So I really appreciate your, let's say, the time that you spent over here during, I mean, for people in Europe, this was lunchtime. So thanks for being here during your lunch break and listening into my short little story. So feel free to, stay in touch with me, ask questions and interact, because in the end, we're all still learning. We're all trying to figure out the best way to help our engineers not to be overburdened, and to deliver the best possible value with the capacity that we have. So with that, I'd like to thank you a lot. I know that there are a couple of questions in the chat, so thanks a lot for sharing the questions. I'll give the microphone to Jonathan.